Well, we got the clock. We got the clock done. I was interrupted by the clock maintenance guy. He came. Sam, the clock man, tuned up our Westminster clock, grandfather clock. Beautiful. Did a great job. There was a couple notes that were off whack, and he nailed them. Did some oiling, cleaning. Turned out real nice. Okay, sorry about that. So anyway, I got back to wiring. The tender is wired internally to the track as far as sending signals out. It's not connected to the engine. That's next. And I thought I'd just show you what happens when we turn this thing on. So I got AC going to the track, not to the engine. AC to the tender only, and that's with the all-wheel pickup. Okay? So I'm going to turn on the power. Right away you hear a noise. That's the steam pop-off valve. There you go. So the soundboard has its power. Its power is from AC. That's what he needs. That's what he's got right now. There's a little noise on there. I might throw a cap on that and see if I can quiet that down for him, a capacitor to smooth out the conversion. I have the motor outlet to the motorboard. Before I plugged it in, I wanted to make sure I had power, and I checked the voltage. It goes up and down. You can see it goes up and down in brightness with the transformer, and it also is polarity is correct. The right side is red. So that red light means this motor controller will fire up. And if I saw that, I didn't even know what I was looking at. Okay, so that's the red light for the motor controller. Power output, this is the power distribution board. He had to get a haircut for the clearance necessary. His heat sink was a little too high, so I shaved him down a little bit. That was kind of fun. I've rewired my input power down to the wheels, so that's all good. I've tied up to the output on the left side, and that goes to the relay for power to the relay, and I've set it at 5.5 volts. Now turn this off. Power's off, volts drop to nothing, turn the power back on, 5.5. So that is the output of this buck boost board. And I want to show you another thing. If I change the transformer up to full speed and down to 20, 5.5 volts. So that's why this is called a buck boost. Regardless of what the transformer is set at, it's going to give you 5.5 volts. It's a little wasteful, but it gives us what we need. On the motor side, the fan, smart smoke heater, for that it needs 9 volts, and I have it set at 8.0. I start at 8, and if I need it, I crank it up. I don't know if I'm going to be building a board or using one. It looks like I might have to build this board up first. That's not a problem. I should have all the parts. I might try to find a used one so I can get going faster. But in any case, the next step will be to hook up the ground, the power coming in. Power and ground coming in is this piece here. So I can put a socket on there, run that as a separate wire. That's how it should normally work. And that would give 5.5 to that. These pieces are going to have to be tied into a harness, and they go to this 9 volts right here. So they're going to need a little socket to get into that. And that should be okay. I took the speaker off that I had on here so I had more space to do the wiring, reaching everything. So, and there's my little checklist. The right side buck boost is 8.8. I turned it down to 8. Soundboard has the relief valve, and the chuff sounds are good. Left side board was 8.16. That's way too high. I cranked it down to 5.5. I said 5 to 6. I took 5.5. So it's been reset. The light, and we're showing on the motor board, it went up with voltage. Maximum power was 14.6 coming out of the 4B, and it went all the way down to, it looks like 7 at 20%. So this power goes from 7 to roughly 14.6 volts. Probably wouldn't even run at 7. Probably have to get it up to about 8 or 9. So you'll see when we turn this on at what point everything starts cooking. But that's how I run these tests. So anyway, I got the soldering done. The watch the clock cleaner came and went, a little disruption, but nothing problem. You can see I was a little low. I had to put this up on stands, even though I had printed it and designed it right. I actually designed it too low. What I had not considered was the socket that goes into the soundboard for the trigger, for the chuff trigger. I put in a wire socket, and when I did that, it sticks up. So I might have to look at either a smaller socket or a direct wire off of the harness and put it in with the others as the socket between the engine and the tender. And that would flatten that out. Okay, so that's where I'm at. Now I'm going to work on the engine side, start building that harness between the two. Okay, just showing you where we're at and what we're doing and why, and we're going to end up with something that looks like that. Not like that, but it'll look like that on here. Oh, but also here you get to see, this is the all the red parts, you know, are next generation flyer parts. And well, even these black parts, these are all 3D printed, except the wheels and axles, of course, they're metal. But all the PC boards and the 3D printed parts are from us, which is pretty awesome. So this is for the Royal Blue tribute train for the Stingray Corvette, according to Leon. Okay, I'll be back.